In this video, we're going to take a look at how to figure out what sample size is required in order for you to estimate a population proportion. There are two different formulas. The first one is if you have an estimate for p hat that's known. If you use that, then your size n will be a little bit smaller than if you don't know any information about p hat. If you know some information about p hat, then you would use p hat times q hat, and then that's in the numerator, multiplied by z sub alpha over 2 squared, and then you divide by your error squared. So this error is the error that we were calculating for our confidence intervals from the last video. And then if you don't know anything about p, then you would just use 0.25, and that's the largest that p times q would ever be. And so again, that's the only thing that changes in the formula. And when you're calculating n, you always want to round that up. So for example, here, if you were calculating n and you got 502.01, you would still round that up to 503. You want to make sure that your sample size is sufficiently large, so you want it to be at least as big as it needs to be or bigger. You don't want to go smaller, so you'd rather make them, it would be better to make the mistake of having one too many in your sample size than one too few. So, so we always round up if there's a decimal part, and there always will be. So let's take a look at an example. Gap, Banana Republic, J.Crew, Yahoo, and America Online are just a few of the many companies interested in knowing the percentage of adults who buy clothing online. How many adults must be surveyed in order to be 95% confident that the sample percentage is in error by no more than 3 percentage points? We want to use this recent result from the Census Bureau that 66% of adults buy clothing online. So this would be p hat. So we would use the first formula for n. N equals z sub alpha over 2 squared times p hat q hat over the error squared. So since we want 95% confidence in this, we would use z sub alpha over 2 as 1.96. So in the last set of lecture notes, there was a bunch of known or really common ones. So for 90% confidence, 95 and 99. They're also in the positive z-scores table. So they're right here. So they're also in that table, so you can find them there. So 95% would be the 1.96. So 1.96, and that's squared, times p hat, which is 0.66, and then q hat is 1 minus p hat, so that's 1 minus 0.66, which is 0.34. And then we divide that by the error squared, and so 3 percentage points would be the same as 0.03. When you type that into your calculator, you should get 957.83 and a bunch of other decimals. So again, we always round that up, so we would want a sample size of 958. Next, we're going to assume that we have no prior information, and so we use the other formula. So n is z sub alpha over 2 squared, and this time we're going to multiply by 0.25. That's the worst case scenario, and then divide by the error squared. So we still want 95%, want to be 95% confident, and so we're still going to use our z sub alpha as 1.96. And we square that, and then times 0.25, and then we divide by the error squared, and nothing else is changing except for that we don't have any information about p. And so that's still going to be 0.03, and you want to square that. So plugging that into your calculator, you should get 1067.11 repeating, And so we would round that up to 1,068. So we can see that the sample size that we need is a little bit bigger. This really isn't that bad though, considering. So that is how you would calculate a sample size for a proportion. If you have any questions, let me know, and I hope you're having a great day. Thanks.